Hey everyone, this is Kawaljeet Kurmi working as Senior AI/ML Specialist Solutions Architect. And in this session, we're going to talk about Kubeflow on AWS, which is AWS specific distribution of Kubeflow, and we'll see what value it adds to our customers over open source Kubeflow. Now, before I jump to the demo, let us take a quick step back and discuss why customers are choosing Kubeflow on Kubernetes and what challenges they are facing that we are trying to address with our stack. Okay, so what I've seen with many customers who have portability and hybrid cloud requirements, they are taking do-it-yourself approach to build, train, and deploy the custom complex deep learning models. And to do that at scale, they are leveraging platforms like Kubernetes, which works great as an orchestration platform and to orchestrate your machine learning jobs on distributed machines. And on top of that, they use Kubeflow, which is a machine learning toolkit to build, train, and deploy their models, as well as create machine learning workflows. Now, Kubernetes and Kubeflow stack works great. However, there are a couple of challenges. So let me show you that in the screen quickly. Now in the screen, if you see, right, the outer boundary is basically the Kubernetes cluster where we have the control planes and we have the worker fleet of Kubernetes. And on the worker fleet, we have Kubeflow control plane and data plane deployed. Now for the customers who are new to the stack, right, the initial learning curve could be very high. And the second, all Kubeflow control plane heavy lifting infrastructure components like databases, storages, authentication, they're all deployed on Kubernetes worker fleet, as we see in this diagram. Now this makes it really challenging to implement a highly available Kubeflow control plane design architecture with a persistent state, especially in the instances of worker node failure. Third, Kubeflow control plane generates artifacts, right? They could be MySQL instances, artifacts, pod logs, or min IO storage, and that grows over time. And it needs a resizable storage volume, and that means we need to have the continuous monitoring capabilities to ensure that our demands for the storage in the future are met. Now, because the control plane share resources with its data plane workloads, right sizing and scaling Kubernetes and the storage volumes can become challenging, and it could result in increased operational cost. Now that's where AWS Kubeflow distribution comes in, and it provides its own Kubeflow manifest that could address these challenges, and it does that by providing native integration of Kubeflow control plane components with AWS managed services. Now some of the integrations, as you see, are first Amazon CloudWatch, which provides persistent log management, AWS Cognito for user authentication with transport layer security, that's TLS, AWS deep learning container integrations which provides highly optimized Jupyter notebook server images, Amazon Elastic File System, and Amazon FSx for Lustre for simple, scalable, serverless storage solutions for increased training performance. You can also use Amazon Relational Database Services for highly scalable pipelines and metadata store, and our Secrets Manager service to protect secrets needed to access any applications from your Kubeflow stack. And lastly, you can also use our integration with Amazon S3, a simple storage service, for easy-to-use pipeline artifact store. Now with these integrations, you are basically able to combine the open source Kubeflow with innovations from AWS, basically getting the best of both the worlds. Now before we see the demo, right, let's see how does the user experience on Kubeflow on AWS looks like. And I'll use this architecture slide to basically explain how the user is authenticated with TLS using AWS Cognito. Now, starting from the left, user sends an HTTP request to Route 53 with a custom domain to log into the Kubeflow Central dashboard. Now, Route 53 resolves the domain name to the Elastic Load Balancer, which basically manages the traffic to your Kubeflow stack. Now, Elastic Load Balancer provisions the TLS certificate from the ACM service, which is the AWS Certificate Manager. And these TLS certificates enables it to do TLS authentication. Now, if the cookie is not present, the load balancer redirects the request to Cognito authorization endpoint so that Cognito can authenticate the users. Now in this demo, we have created the users in the Cognito native user pool. However, Cognito can also work with external identity providers like the ones which support SAML and OpenID Connect, and also social identity providers like Facebook, Amazon, Twitter, and you can also bring in your own identity providers as well. Now, if you see, Cognito is associated with the domain certificate as well. Now, after the load balancer authenticates a user successfully, the load balancer redirects the user to Ingress gateway, which is part of the Kubeflow service mesh, and it validates the request and forwards the user to the Kubeflow dashboard. Right. So with this background understanding on how the user is getting authenticated and how he's getting logged into the Kubeflow dashboard, let's move to the browser and see what all he could do while being on the Kubeflow dashboard. Right. So this is how the dashboard looks like, and I've logged in using my user credentials. Now, the first thing you need to do is select your namespace from this namespace dropdown. And this namespace corresponds to your user profile, and it will define the permissions on what you can do on the Kubeflow dashboard. Now, once my namespace is selected, I'll go to the left navigation and we'll click on the notebooks. And this will take me to the notebook UI manager. Right. And in this screen, you will see all the previous generated notebooks that you might have created. We'll go ahead and create a new one using this link. Okay, so we can name our notebook. Right. And then the namespace will be the one which you have logged in and you have selected. And then the next you have to do is select a particular Jupyter Docker image, which will back your notebooks and will host a server, right? And there are two options to select that image. One is the custom image, where you can basically, if you've already created a Jupyter image and you have pushed that to Docker repositories or ECR repositories, you can mention that repository URL here and use that as your Jupyter Docker image. And second, you can leverage the standard images that comes as part of our AWS Kubeflow distribution. And here we provide deep learning container integrations. And if you see, we have available PyTorch and TensorFlow Jupyter Notebook images as of now. These frameworks and all of its interdependencies, like other CPU drivers, GPU drivers, all of them have been packaged together and they work really well. The best thing is you just have to select this particular framework of your choice and you can get started with it right away, right? So I'll just go ahead with selecting this particular image, and then we'll have to select, specify the CPU and RAM that is needed for your work on Jupyter Notebooks. You can also select any GPUs that will be needed. And then you define your workspace volumes or data volumes. Now here is a place where you can integrate our AWS EFS and FSx for Lustre file system for increased training performance. And those file systems could be used either for workflows or either for workspaces or for data volumes, right? And once you've done that, you select a particular configuration. So here I have specified and applied one configuration to this user profile, which will enable my Jupyter Notebook code to interact with the pipeline SDK. And once this is done, we'll click on launch. Right. So we'll basically go to the notebook which we have previously created so that we can save on some time. So this will take us to the Jupyter Lab interface, where we'll pick up one of the Jupyter notebooks to demonstrate the example. Okay. Now this is a Jupyter Lab, and we have opened up our notebook. Now this basically is a notebook where we are trying to solve a data science example, a problem for taxi cab, basically Chicago taxi, where we are trying to predict the trips which results in the tips greater than 20% of the fare, right? And this code demonstrates a continuous training using a training evaluation check recursive loop. And there is a main pipeline that trains the initial model, and then gradually it trains the model some more until the model evaluation metrics are good enough. Now we'll use the Kubeflow pipeline Python SDK, and we're using version 1.8.4. And let's run all the cells together using this command. And while this is running, we can talk through these cell descriptions. So once we have installed Kubeflow pipeline, we will import the required libraries, and then we will load the pipeline components. Now these components are basically what will define your steps in your machine learning workflow. And each of these components basically runs a container which has your code inbuilt, and that code is an implementation for a particular step. And these component specifications will define what those container images are, what are the inputs and outputs from those images, and any kind of metadata that you want to specify. And these specifications are specified in YAML and are well documented in Kubeflow documentation. Now, all of these specifications that have been already created, you can load those specifications using Kubeflow pipeline SDK functions called load component from URL. And then this will create a factory function using which you can create the container operators, which will act as an interface for your container implementation for that particular step. Fine. So this is a place where we are loading all of the components, and then we will define a recursive function, right? This recursive function is basically training our XGBoost model with the learning objective of squared error loss. We're going to make the predictions, and we're going to calculate the matrix. And if the matrix of mean squared error is not less than or equal to 0.01, we're going to train that model again in the recursive loop until our learning objectives are met. Right? And this is kind of a sub pipeline that will be fed into our main pipeline. And this recursive functions is defined by a decorator function called graph component, which is available in our Kubeflow pipeline Python SDK. And finally, this is a place where we create our main pipeline. And in this pipeline, we fetch our Chicago taxi trading data set. We will do data transformations. And this is the first training run that executes with the learning objective of squared error. And once this model is created, we will feed that model to the recursive loop. And that loop will keep training that model until the squared error loss comes less than or equal to 0.01. Right? And this is, again, using a decorator function of pipeline, again, provided by the pipeline SDK. Cool. Now, once you have defined your pipeline function, we'll have to compile that, right? And there is a compiler function available in our SDK, which basically compiles that pipeline and converts that into a YAML configuration. And that YAML configuration will be fed in the background to the underlying Argo engine, which will execute that and will create our workflow. So that's all abstracted away from the users, and all we have to do is create a client to our pipeline REST API. And using that client, we will submit a run for this particular pipeline for this particular experiment called Kubeflow, right from the Jupyter notebook. And from here, once you click on the run details, this will take us to Kubeflow pipeline run interface, where you can see the execution of your workflow. Now, if you see here, our workflow has been executed successfully. Every step is showing in green. That means every step has successfully executed. In case there would have been any error, that particular step would have been shown in red, and you could have clicked on it and could have seen what errors are there in the logs to debug it. Now here in this page, to support the pipelines, the AWS distribution provides two integrations. One is with the AWS S3, which is simple storage service. Now if you click on any pipeline step here, right, this will give you the description on what are the inputs and outputs of that particular step, and what are the outputs that got generated. Now, if you see, this is the step where we are training the XGBoost model, and that model is generating this artifact. And if I open up my S3 location, I could see that all those artifacts which we see on the pipeline step metadata could be available in your S3 location. And this is a place where you can go back in time, could access the artifacts for any of your previous runs, and this is really, really helpful in model governance and for any kind of monitoring and traceability solutions. And the second integration that we provide here is with our Amazon Relational Database Services, which could be used to track all the metadata for every execution for the pipeline that you have run or your teams have run, right? So all the pipeline that you have created before, any experimentations that you have created, all the runs tied to that experimentation, all those details could be seen from a relational database service, and you can query that using the SQL command. Now, let's probably see that how it looks like, right? So I'm going to use Amazon Cloud9 environment. This is basically a web interface to do your coding. You can debug your coding all from the this browser interface. And here I'm actually using my SQL client image to create and run my SQL client, and then I'm connecting to my RDS database, which I have installed as part of the AWS Kubeflow distribution. Now with this, I can actually the command connect to a particular database. You can see all the tables that are created in the database, and if you see, there are tables to track your experiments, your jobs, your pipelines, and all the details for your pipeline runs and metrics. Now, if we have to query the experiment table as an example, you can see that these are the unique IDs which got assigned for every experiment. There could be a description if you would have provided. You can see what namespaces those experiments are tied to, and what is the storage state for those. And then really, if you see the other tables here, right? For example, run details. You can see that these tables provide the column names like experiment unique ID, and these are the columns which could be joined with your experiment table to really go a little bit deeper and see what are the statistics metadata for that particular run, right? And this is just one of the examples to connect to the RDS. There definitely are multiple other ways, more user-friendly ways to connect to it. You can use SQL Workbench or any other SQL client to connect to that RDS and can access this information through any kind of analytical platform. Or you can use Tableau, QuickSight Dashboard, or others to visualize this in a better intuitive way, right? And this concludes our demo. You can probably find more information on AWS Kubeflow distribution on our formal AWS Kubeflow documentation, and there are certain blogs that we have created recently, which actually walks you through the detailed step-by-step installation steps, and then you can follow that, bring this distribution up, and then follow those examples that are provided in the documentation and in the blog. So that concludes the demo. Thanks again for joining me for this session. This is again Kavaljit Kurmi, working as Senior AML Specialist for Amazon Web Services. Hope to see you again in the next session. Thank you.